Hi everyone, welcome back. In the previous tutorial, we added in movement using sine and cos to make sure our player can move smoothly around the screen, wrapping at the edges to make sure we don't fall off the edge of the screen. Today, we will be adding in momentum to give our spaceship a more spacey vibe, where of course we wouldn't expect any friction, although we will be adding in a small amount to make the control a bit more enjoyable within the game. As always, we want to make sure the code from the previous tutorial works by using cargo run. If you don't have the code at this point, you can run git checkout tutorial 6 and it should give you a snapshot of the code at this point. Today, we will be using vectors. Vectors build on what we started to look at in the previous tutorial using sine and cos to map to our x and y coordinates, but will do a lot of the conversions for us. For instance, being able to convert between x and y coordinates and calculating the hypotenuse between the two, as well as giving us functions like normalize, which allow us to scale the x and y coordinates back to a unity circle in case they get too big. We're going to add the Vector2D crate into our cargo.toml file, and we'll be using version 2.2.0, although at the time you see this there may be a more up-to-date version, so check the documentation linked in the notes under the video to see if one is available. Then we'll go to our components.rs file and add in a reference to this newly imported crate. Then we'll scroll down to our player declaration in order to add in an impulse and current speed vector to that object, and the generic types of those vectors will be f64. Then we need to navigate to the game.rs file and scroll down to the load world function, where we need to add in those values to make sure they're initialized correctly. In this case, we'll just set them to 0.0 and 0.0. And of course, because we're using Vector2D here, we also need to import it at the top. Then we're going to create a new function underneath our update function, and this will apply the new impulses and speeds to the player. Our key presses will no longer be directly applied to the player, but instead will create impulses to act on the current direction and speed of the player. The new function will be called update movement and will take the position object as a mutable reference as well as the player object, also a mutable reference. The first thing we want to do is apply friction to the current speed, which we can do by multiplying by a constant, which we will add in a second. And above this function, we will insert that constant of type f64 and value 0.99. Next, we will add the current impulse, which we will set elsewhere, to the player's current speed. Another great thing about the vector library is it'll do all of this maths for us very easily. Then we need to add a check to make sure the maximum speed has not been exceeded. If it has, then we will limit the speed to the maximum by first normalizing the vector and then multiplying our maximum value. Then we will define our max speed constant just next to the friction constant. Then we will update the position x and position y by getting these components from the current speed. And finally, we'll reset our impulse back to a vector of value 0, 0. Scrolling back up to our update function, we will need to update the player's variable to be mutable, and we will need to get the right storage version of that from the entity component system. Then we need to make sure we get a reference to the player. Previously we were ignoring it in the join. And then we will call our new update movement function, passing in both the pos and player variables from above. Next up, we need to change our movement code from before. We will create some new variables, movex and movy, and store the values in there rather than applying them directly to the posx and posy variables. Then we create a new variable called movevec and store the values of movex and movy as a vector in this variable. Finally, we're going to add this to the player impulse. We could just set it, as we know it's already zeroed from the last call, but this allows us to add other things into the impulse later, for example, pushing explosions. Running cargo.run, we see we forgot to make one of the references to the player entities mutable, so we add mute to that. And we run cargo run again, and we can see we have the player drifting around the screen as we'd expect. The momentum is being preserved, although our 0.99 friction does stop the player eventually, and we can also see that the screen wrapping is working as we'd expect as well. Thanks for tuning in. I hope it's been interesting for you to see. I hope you'll join us in the next video where we'll start to have a look at the specs event dispatcher and add some asteroids into the system. If you enjoyed this video, please click on the subscribe button so you won't miss any in the future, And if you have any questions or comments, please leave them down below. Thanks for joining us today, and hope you have a great day. Bye for now.